Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, GIMS Engineering Management Technical Campus, Greater Noida. The subject that I teach in BTech 7th semester Electronics and Communication Engineering students is Optoelectronics and Optical Communication System. This is the main subject of final year students. And the topic that I will discuss today is attenuation in optical fibers. Well, before definition of attenuation, first I just discuss what are the main reason of attenuation in optical fiber, and it's a major issue in optical fiber. Attenuation is one of the major issue that optical fiber engineer face is the attenuation. The mainly cause of this attenuation in optical fiber is absorption. Uh, some light maybe absorbed, you know, absorbed by optical fiber. Scattering, lights are scattered throughout the optical fiber. This is also a loss, and there is a precaution that need to handle optical fiber, that we have to avoid bending. And if the fiber is bending, then bending loss come in the picture. And because the reason behind bending loss is that the total internal reflection disturb inside the optical fiber, right? Because the light travels through a principle of total internal reflection, right? So basically, three phenomena we face in optical fiber as far as attenuation is concerned. Absorption, some light is absorbed by the fiber material. Scattering, lights are scattered. When light are scattered, then some part of the light come in cladding region, and this is a loss. And when the fiber is bent, then bending loss come in the picture. So what is attenuation? Attenuation actually is the loss of optical fiber as light travel along the fiber, right? So attenuation nothing but it's a loss of optical fiber. If you use optical fiber and at one end, if you measure and if you give 100% of the light at one end of optical fiber, and at the other end, if the light comes to be only 40%, then we can say that 60% of the light is attenuated, and this is the attenuation, right? So signal attenuation is defined as the ratio of optical input power to the optical output power, right? So if you want to find out the attenuation of a particular fiber, what you have to do, you have to measure with the power meter what is the input power at one end of the optical fiber, and then you have to measure the output power at another end of the optical fiber. And if you take the ratio, then this attenuation is calculated in that manner, right? So signal attenuation is measured by the ratio of optical input power Pi to the optical output power P naught or PO. Okay. So optical input power is the power injected into the fiber from an optical source. So at one end where you want to enter the optical light inside the optical fiber, you need a optical light, and optical light is coming from optical source. So what you have to do, you have to couple optical source to the optical fiber, right? And optical output power is the power received at the fiber and or optical detector, right? So what is optical input power? Optical input power is coming from optical source. And what is optical output power? Optical output power actually it is the input of optical detector, right? You can say that. Now if you want to calculate numerically the attenuation always measured in terms of dB per kilometer. So if you actually what you have to do, you have to convert attenuation. And before previous slide, what we have to see that signal attenuation is nothing but is a ratio of P input upon P output, power input upon P output. Now you have to convert this in a log, and to convert this ratio in log, what you have to do, you have to take log to the base 10 and multiply by 10, and this quantity become dB, right? So, so signal attenuation always measured in dB per kilometer, right? So attenuation is 10 log to the base 10 input power upon output power and divided by a length of the fiber. So it is comes to be dB per kilometer. This length is in kilometer, right? So attenuation always measured per unit length, dB per unit length, maybe kilometer or maybe meter. It depends. When you take L as a kilometer, it comes out to be dB per kilometer. If you take L as a meter, then it comes out to be dB per meter, right? So therefore, the unit of attenuation is decibel per kilometer, right? And each mechanism of loss is influenced by fiber material properties and fiber structure. Actually, the mechanism of this loss, when the loss come in the picture, it is because of the fiber material. You know, some material because fiber manufacturing from glass and plastic material, and these material have the property to absorb the light. So absorption come in the picture because of the material that we use to manufacture this optical fiber. And fiber structure, this is also be the case because fiber structure in the sense that whether you use multi-mode fiber or a single mode fiber, whether your diameter of the core is large or small, right? So some loss is because sometimes what's happened if the core diameter is such a small, then it's very difficult to enter the 100% light into the optical fiber. So in that way, we can say that the each mechanism of loss is influenced by fiber material properties and fiber structure. So fiber material properties and the fiber structure is is the problems that we face as an engineer as far as the attenuation or loss is concerned. Attenuation actually means loss. Loss means attenuation, right? However, loss is also present at fiber connection. Sometimes you have to connect if the distance if the distance of the communication is large, then what you have to do? You have to use multiple optical fibers. And when you use multiple optical fibers, you need to connect two fibers at some distance. So when you connect two fibers, then there is a connection loss. That's why we say that. However, loss is also present at the fiber connections. In the same way, when you have a two water pipes, if you not join two water pipes correctly, what's happened? When you open the tab of water, then some water is to be coming out from the joint. In the same way, if the fiber connection is not properly done by you, then what's happened? Some of the light is to be comes out from that joint. So loss is also present at fiber connectors, fiber splice, and coupling loss. So coupling loss is to be there. Then there is always some types of imperfection present at fiber optic connections that cause some loss of light, that we already discussed. Some imperfection means if you are not joined to optical fiber properly, then you face some loss. Some light is to be coming out from the optical fiber, and that count to be lost because light is lost means energy is lost. So the out at the other end of the optical fiber, you get you know small optical energy because mainly energy is lost at the joint. So imperfection present at fiber optic connections that cause some loss of light. The design of optic system depends on how much light is launched into an optical fiber from an optical source and how much light is coupled between fiber optic components such as from one fiber to another fiber. Now this point, to understand this point, what we have to do? We need a optical energy, optical light, and that optical light come from optical source. Now what you have to do when the light is coming from optical source, what you have to do, you need to launch this light into the optical fiber. So if the launching is not done properly, then what's happened? If the 100% of the light coming from optical source, and if the launching of this energy into the optical fiber is not done properly, say for example, out of 100% of the light coming from optical source, sometimes only 60% of the light is entered into the optical fiber, 40% is lost. So at the beginning, you initially you lost 40%, and rest of the rest of the 50% lost because of the fiber structure and attenuation, right? So that's why we can say that we need a proper launching of light. What we need 100% of the light coming from optical source is launched into the optical fiber, right? So the amount of power launched from a source into a fiber depends on the optical properties of both the source and the fiber. This is also true. The amount of optical power launched into an optical fiber depends on the radiance of the optical source. An optical source radiance or brightness is a measure of its optical power launching capability. Right. Try to understand this point. Radiance. We need a good radiance, good brightness, good intensity of light coming from optical source. Right. So if you want to launch a light properly inside the optical fiber, you need optical source radiance, brightness, good intensity. Then you are able to launch this light that is coming from optical source into optical fiber. Then optical loss is also a log relationship. The loss in optical power through a connection is defined as attenuation loss is equal to tan log to the base 10 pi upon p naught. P is the input, P is the output. This is we already discussed in previous slides. So this is the formula. This is the mathematical expression that gives you the attenuation loss in dB. And if you divide this particular expression by a length of the fiber, then you get attenuation per unit length, right? That this particular thing we already discussed in previous slides. So fiber to fiber connection loss is affected by intrinsic and extrinsic coupling loss. There is a concept of intrinsic and extrinsic coupling loss. Intrinsic means it is the loss due to the fiber characteristics, right? Fiber characteristics means the material also included in that, because of the material that are used to manufacture the optical fiber. These material caused sometime a loss, and that loss come in a category of intrinsic losses. Extrinsic losses means these are the losses that come in the picture when you join two optical fibers and some light is to be leaked at the joint, then that loss come in the category of extrinsic losses. So in this way, intrinsic losses and extrinsic losses are to be seen when we deal with optical fibers, right? And you can't do anything with that because the material that are used to manufacture optical fiber causes attenuation. So you can't do anything in that. Of course, you avoid this extrinsic losses by proper joint of optical fiber. That is also true. So this particular topic is very much important for the students, because this is a straightforward topic as far as your syllabus is concerned. And most of the time the questions asked, what is attenuation, explain attenuation, how we measure attenuation, what are the cause of attenuation, what are the factors that are responsible for attenuation in optical fiber. So generally these questions may be asked in coming examinations or had been asked many times in main or end term examination. So this is basically a very straightforward topic of the of the second unit that we start today, and the
the heading of this particular unit is attenuation. So this unit comprises of different types of attenuations that are faced by the engineer when deal with optical fiber. So this is very important topic. Students should go through the books and prepare a notes about the attenuation, right? So thank you very much.